Your LLM prompts need to fetch real-world data before generating responses, but blocking your entire application while waiting for APIs isn't an option. We'll implement both synchronous and asynchronous prompt functions in FastMCP, showing exactly how to handle external data fetching without freezing your server. You'll see the clean pattern for mixing immediate string generation with async operations like API calls.
#synchronous prompt. @MCP prompt. Def simple question SDR. Generates a simple question to ask the LLM. Return F question. #asynchronous prompt. @MCP prompt. Async def data-based prompt data ID, SDR. Generates a prompt based on data that needs to be fetched. In a real scenario, you might fetch data from a database or API. Async with AOP, client session, as session. Async with session, get https://API example, com/data/data ID, as response. Data equals await response, JSON. Return F, analyze this data. Data content.
This demonstrates the prompt has code pattern for LLM interaction design. The approach treats prompt templates as first-class functions, using Python decorators to register reusable message generators with the FastMCP framework. What makes this distinctive is the seamless integration of dynamic content generation with static template structure, enabling prompts that adapt to runtime data while maintaining consistent output formats. The pattern works by decoupling prompt definition from execution context. Decorators transform Python functions into declarative templates, where parameters become dynamic slots and return values define message structure. This separation allows developers to focus on content logic, while the framework handles serialization, validation, and protocol compliance automatically. The async support further enables prompts to incorporate real-time data fetching without blocking the LLM interaction flow. This approach solves the problem of prompt fragmentation and maintenance in LLM applications. By centralizing prompt logic in version-controlled code rather than scattered text files or API calls, teams gain type safety, reuse, and the ability to test prompts programmatically. The pattern shines in systems requiring dynamic prompt generation, like data analysis tools or multi-step workflows, where static templates would either limit functionality or require complex string manipulation. The trade-off is a slight learning curve for framework-specific decorators, but the payoff in maintainability and consistency justifies the investment. Let's break it down line by line.
#synchronous prompt. @MCP prompt.
The @MCP prompt decorator marks this function as an AI callable prompt template. It transforms the function's return value into a structured prompt for the LLM while preserving type hints and docstrings as the prompt schema. This is the standard pattern for defining reusable prompt templates in FastMCP.
Def simple question SDR.
This defines a synchronous prompt function that takes a string question and returns a formatted string. The type hints enforce input-output contracts, while the decorator exposes it as an AI callable prompt in the FastMCP system.
Generates a simple question to ask the LLM.
This docstring defines the prompt's purpose for AI models. It becomes part of the tools schema, guiding how the LLM should interpret and use this function.
Return F question.
This formats the input string as a direct question prompt. The consistent question prefix creates predictable structure for LLM processing, improving response reliability.
#asynchronous prompt. @MCP prompt.
The @MCP Prompt decorator marks this function as an AI callable prompt template. Unlike tools that perform actions, prompts define how to format questions for the LLM. This one enables dynamic data fetching before generating the final prompt.
Async def data-based prompt data ID, SDR.
This defines an async prompt function that handles I/O-bound operations without blocking. The async await pattern enables concurrent data fetching, crucial when prompts depend on external APIs or databases.
Generates a prompt based on data that needs to be fetched.
This docstring documents an async prompt generator that requires external data. It signals to developers that this function handles I/O-bound operations, unlike the synchronous version above, and justifies the async await pattern used in the implementation.
Hash in a real scenario. You might fetch data from a database or API. Async with AOP client session as session.
This establishes an async HTTP client session using AOP's context manager pattern. The async with ensures proper connection cleanup after the block executes, preventing resource leaks. Critical for production APIs where dangling connections accumulate design debt.
Async with session. Get https://API example com/data/data ID as response.
This makes an asynchronous HTTP GET request using a context manager. The async with pattern guarantees proper connection cleanup after the request completes, preventing resource leaks. In async code, this is the standard way to handle external API calls.
Data equals await response, JSON.
This awaits and parses the JSON response body. The await suspends execution until the full response arrives, while JSON converts the raw HTTP payload into a Python dictionary. Critical for async workflows where you need structured data before proceeding.
Return F analyze this data. Data content.
This formats the fetched data into an AI-ready prompt. The F string embeds the dynamic content from the API response, creating a structured instruction for the LLM to analyze the specific data payload. This pattern transforms raw API data into actionable AI prompts. Async prompt pattern. FastMCP 2 unifies synchronous and asynchronous prompt handling through the same decorator, enabling seamless integration of I/O-bound operations like API calls or database queries directly within prompt generation. The async prompt must use async with for resource management, as synchronous context managers will block the event loop. This pattern eliminates the need for separate prompt and data fetching layers, simplifying architecture while maintaining responsiveness.
The prompt that waits on nothing waits on everything.